All right, 17, we want to find the zeros of the polynomial function. And then same thing, enter domain, and then make it a rational function. So to find the zeros of this, x squared, it's not in factored form. I'm going to factor it so I can hurry and figure out what the zeros are, because it's so easy in factored form. So multiples of 20, or factors of 20, can you see that -4 and -5 add to -9? So these are my roots. X minus 4, x minus 5. I set it equal to 0, and I solve each one. So x equals +4 and x equals +5. And then remember, domain of a polynomial, like if I graph this, there's not going to be any breaks in it. It just goes -infinity to +infinity. So x squared minus 9x plus 20. See, it's just a parabola, so it goes forever left, forever right. But what happens when I put that over a fraction? Oh man, I'm gonna have to type it again. That's okay. X squared minus 9x plus 20. We get asymptotes. Okay, so let's see. Find the roots. Again, when 1 is just the numerator, when we set that equal to 0, there's none. There's no roots. But the domain, we get these breaks at 4 and 5. We get what we call asymptotes. So our domain is going to go from -infinity to our first asymptote 4, and then a break from 4 to 5, and then 5 to infinity. And it's hard to see on this graph, but I bet if I zoom out, see, there's the other line. So see how I have 3 chunks of lines? That means there's going to be 3 chunks of domain. And that's our domain. So let me go type it in. I solved for x and got 4 and 5. The domain of a polynomial is infinite. There's no roots when the numerator is 1. And then our domain still goes -infinity to infinity, but you take breaks at the asymptotes.